And our next session is how to build a shielded Zcash mobile app. Oh, I wonder how that's done. With Paul from Edge. So welcome, Paul, to the stage. Yeah. Yeah. You're welcome.
Hi, everybody. So we have one of our workshops here today. I think one of the fundamental necessities, obviously, in the cryptocurrency space is a mobile app. And while Zcash may have started with the gruesome command line send and receive, we do have a plethora of mobile apps now built by the community, including companies like Edge. And one of the things that we had contributed in the process of building Edge is an open source library that anybody can use to build a mobile app, specifically on the React Native platform. And so let's talk about the process and also kind of the whys. Quick introductions. Oops, what happened here? Sorry. Oh. Had the wrong slide, I was at the very end. Okay, so quick introductions. My name is Paul Puey. I'm CEO and co-founder of Edge. Used to work for NVIDIA. I am both CEO and also a software engineer. I still kind of get into the nitty-gritty of developing with our team. Still write a little bit of code, but also help kind of run operations in the company as a CEO, probably more so should do. Spoken at a dozen different crypto conferences and happy to share some of the insights and thoughts that have accumulated over, gosh, almost 10 years of working in the cryptocurrency and Bitcoin space. So a few developer assumptions. I'm going to assume some people here aren't very technical. This is going to be a bit of a slight coding workshop. I'll try to make it fairly high level. So for those of you that are technical, you should be able to kind of understand what's going on, especially if you happen to build within the JavaScript, TypeScript, React world. If you're not, and maybe you have some interest in building a project, hopefully you can at least see how easy it is now, based on the code examples, how easy it is to build something that maybe you want to see in the ecosystem and bring on some developers to do so, whether it be a payment processing app. I've heard from quite a few people that like, gosh, we need something for our merchants to be able to receive money. Well, this could be a way to build that application that's focused on that. One of the big challenges in the crypto space is a lot of projects want to kind of do everything, and we get pressure to incorporate functionality into our app just because you can. And there's low friction from the viewpoint of regulatory, you need licenses, this and that. It's just software. It's the beauty of crypto. But at the same time, you want to build an app that has a specific purpose, and payment processing isn't our focus. That could be a great example of an app that people could build for Zcash fairly easily with this library. For those that do want to follow along, these are the GitHub repos. We built a short URL right below. So for example, edge.app./rnz will get you to the react-native-zcash GitHub repository, or RNZD, which is the demo app. And what I'm going to be going through today is the demo application that uses the library. So you can see the different steps taken in order to build an app that does address generation, key generation, and basic clearing of balances, transactions, and then sending of funds. All right, let's hop right into the demo here. Okay, so for those of you that are unfamiliar with React Native is a mobile development framework that is actually starting to transition to enable people to write desktop-based applications. But the beauty of React Native is that it is cross-platform, right? You can build once and deploy to both iOS and Android, and to some degree on desktop, but you get relatively native level performance. So you get nearly the performance that you would get if you're writing a native app in the two different languages of the different mobile devices. So what I have here is what's called this initial commit, which is when you just create a bare bones demo React Native app, this is all the code here on the right side that you'll get dumped. And you don't write any of this. There's a little command you run, React Native init, and it creates this little demo app on the side. So this is an Android emulator. All right, it looks just like a little Android device with its buttons on the bottom, and all of that gets created for you within a few lines, a few commands, and that's simply it. So what I'm gonna do is take this demo app and slowly trim it down and put Zcash functionality right into it. This set of commits tells the story from a very bare bones React Native app to how to get it to Zcash functionality. So what I've done is I've structured each of these changes one by one to start from the beginning into, boom, I can send and receive, get my balances and transactions in for Zcash. So first thing I did is simplify that user interface. You see this, all this user interface, it's more than we really need. I'm going to simplify it to bare bones to what's frequently called hello world in the development world. And here you can see the changes I made. I ripped out, it's all red, I ripped out a bunch of code, and there's my hello world right there, right? I'm just going to make a little text component, write little hello world. Nothing else going in there, all of that other stuff you saw is just getting ripped out. And I'm going to go ahead and reset to this guy, reset, hard, boom. And now you can see there's our app. And so with React Native, you have live updates. You change the code, the emulator or even the real device automatically reflect the code changes. I don't have to compile or anything like that. And you can see there's the little hello world, right? Zooming right into it. And so we'll use this as a little canvas to show the different updates to the application. So what's the first thing I'm going to do? I'm going to include the library. All right, so here are the changes necessary to include the library. Primarily, you add react-native-zcash. That's the primary library that we built. This is built on top of ECC's iOS and Android libraries that do automatic synchronization and whatnot. I'll be the first to admit, as many people know, a lot of the mobile wallets in Zcash, the ones that use the ECC library, are very slow at syncing right now, especially if you have an older wallet that was created before what's known as kind of like the little spam attack. We don't know if it was real spam, but a lot of transactions hit the network. It takes a lot longer to synchronize. We are going to be updating this library with some of the optimizations that the ECC team have put into place, but that's probably about a month or 2 months away. But know that this is the same library you'll be using. So adding that library into your list of dependencies, run yarn. Yarn is a command to go and incorporate those dependencies. There's a few other things that need to be added. Those are all in the README of the GitHub repository, but relatively straightforward from a developer's point of view. So I'm going to go ahead and then show next commit is adding iOS support. So if you want to develop on iOS, there are a few other things that you have to do. This is a script that updates what are called checkpoints. So many of you might not understand what checkpoints are. Checkpoints are a way to prevent the application from having to sync from the very beginning of time, right? From block zero. If you had to sync from block zero all the way up to now, you could easily take days, weeks to synchronize depending on your internet connection speed and speed of your phone. So checkpoint basically allows sync from the most recent checkpoints, and checkpoints are updated about once per week. Checkpoints will come with the library. When you install the library, the last time the library is updated, the Android checkpoints will be updated. This little script copies those to iOS. So that way, you'll be syncing with a brand new wallet, not with an old one, but with a brand new wallet, you'll be syncing from the last checkpoint. So at most, you'll be approximately about a week old. So that's one thing you do have to do with Android. And pod files are kind of iOS's version of a package manager, so you'll have to update those, and all these commits show exactly the changes that need to be made. There won't be any changes to the app, so I'm not showing any screen updates. It's all still hello world. But now we're going to do actual functionality. So let's generate a spending key. So I'm going to look at the differences here. So in generating the spending key, there's an object in react-native-zcash called a key tool. It has various methods on there for helping generating of the key. For those of you familiar with React, creating what's called a use effect, which is a function that just runs once in the app because of the parameters I've given it. And here we're simply taking the key tool, calling derive spend key. You do need to have your own random number generator. I'm not giving a lesson on how to create proper random numbers. As we know, that's a very important part of cryptocurrency. Generate your own random entropy. We do everything in mainnet here, so I'm not using testnet, just go right to it. Test the real deal, Holyfield. So generating that spend key, we're setting that spend key as kind of global component state. And then you can see I replaced the hello world at the bottom with just simply printing the spend key. And then you can see it. So I think there's actually a tiny bit of money on the spend key, so for any aspiring people, they can actually take the money if they really wanted to. I'm going to go ahead and hard reset to this commit so you can see what changes in the app. And then there you go, there's a spend key. I'll go ahead and zoom in on this if you really wanted to take the money. Spend key, and it's this long, ugly string. This is not the key that someone's going to write down and back up, but it's part of what you'll need for the rest of the SDK to actually spend money, and then generate public and private keys. That is derived from the random hex, and that's derived from the mnemonic that you would normally generate, which is like 12, 24 words. And there. So that's kind of the first step, generating a spend key. Not something you'd show the user, but you would hold internally within the application. Now comes the first interesting thing, generate your address. You need a Z address so you can actually receive money. Let's see, that's the spend key. Let's look at generating a Z address. All right, so in addition to the key tool object, we have the address tool object. And I've set a couple other state variables in my component, one for the view key and one for the address. So you generate a spending key. From there, you're going to have to generate what's called a view key, not another thing that the user generally sees, but you store a state inside of your app. And then from that, you'll generate an address. So I've got a little bit of logging information, so I log onto the console what the address is. And you can see it's fairly straightforward. This is the bulk of the code that uses the SDK. So derive viewing key, you'll use that same randomness that you had generated, random hex. And then from that view key, the view key that gets returned is not just text, it's actually an object. And you use one of the parameters in that object to derive your shielded address. And this talk is entirely about doing a shielded address wallet. We're not talking about doing the standard transparent address, just because who wants transparent addresses, right? Who wants to send and receive where everyone can see what you're doing? So pretty much 2 lines of code to generate the address. I set the address, and then I view it. So these are the text components that show the view key and the address. And so let's reset that. Hard. Boom. Let's see what happens. There we go. You can see there's our view key, and then there's our address, ZS1, JS, RJ. Now that is the thing that you would normally show to a user if you're building a point-of-sale app. Use a QR code library, embed that into the library. There's also some protocols to specify the amount that would go into the address. You can look up exchange rates. Obviously, we're going to do a very basic, app here. We're not doing full-blown wallet application, just how to use the SDK. But there's your Z address. And in essence, really with just, from the viewpoint of the actual SDK, just a few lines of code, right? This is by and large the bulk. Everything in this init function is you interfacing with that SDK. All right, what's the next thing we want to do? There is an object called a synchronizer. So the way that ECC designed the SDK is that it's a very stateful SDK. All right, it runs as an engine. You start this thing called a synchronizer, and it runs in the background. You feed it the keys necessary, and it will grab your transactions, calculate your balances, and you can talk to it for sending money. So there's this process of setting up and starting this thing called a synchronizer, and we'll walk through that. So there's a few imports here, the configuration of the initializer. We're going to set a couple of variables again, which we're going to display as the synchronizer updates. One is called a status, and another one's called an update. And those come in asynchronously. They just kind of come in the background. So first thing I'm going to do is going to get a birthday height, because we're going to tell the synchronizer when to start scanning. Right? You're basically saying, here are my keys, but I know that they were created as of a certain height. Don't bother scanning before that point in time. And so you can use the key tool to get that birthday height. In a way, this is a bit of a misnomer. This is actually going to query the network, ask the Zcash network, what's the current height? So it's not truly a birthday height, it's really just getting the current height. And then we initialize the synchronizer. Here's where you specify the network. We're going to go work on mainnet. You do need a host and port. This code happens to now read from a config file where you can put your Light Wallet D server or one available on the network. You put the URL of that host and the URL on the port. This is kind of the example format of the config file, right? Where there's my random hex that I had put in, the host, so my domain host, and then of course the port. Let's see here, birthday height, and then we have a config for the initializer. This is what we were just talking about. You do need to pass the initializer the view key, right? So the synchronizer. The view key allows it to decrypt your transactions off the network. So it can't spend it, but it can decrypt it to show your balances and transactions. And then you have to give it an alias. An alias allows the synchronizer to have multiple wallets going at the same time. All right. for different keys, but you specify an alias for each one. And it's just a human readable string. I'm calling this one my Zcash wallet 1. And then there's that birthday height that we queried ahead of time. Then we call make synchronizer with that config. And then we subscribe to updates. So these are the asynchronous events that come in as the synchronizer is running in the background. And we don't have to deal with a lot of that background operation. That's kind of the elegance of the ECC library. It does all of that hard work, and we're wrapping that with React Native. And then we say start. And there's an equivalent stop synchronizer call as well. But once you start it, that engine just starts running, and it starts feeding you updates. And I think this is now currently synced because I ran it earlier this morning. Let's go ahead and enable that commit and see what happens here. Oops, my Android app. Note that development environments are a little unstable, so sometimes you've got to restart them. Yarn Android. Let's see here. Yarn Android, as I typed in, is the command to just simply compile and launch the app. Boom, here we go. So it synced pretty quick because I was relatively up to date. Let's zoom in here. There was the line that had our address. This is the line that shows us our status. And this is the line that shows us kind of updates as they come in. So let's look kind of like line by line at what you get back. So you get a little object back. You get the current network block height on update. So as the block height changes, you asynchronously get called with an update that says, here's the current block height. Scan progress goes from 0 to 100, which is the progress of which the library has scanned through all the downloaded blocks. So that allows you to put some update to the user, a little progress bar or whatnot. Last scanned height is the block height that it is scanned from when it last had downloaded, and the last downloaded height. So there's two parts of synchronization. One is downloading the blocks, and then another one is scanning through them to look for your transactions. And the updates give you the height of the progress of both of those. So here's where we last downloaded, and then here's where we last scanned. And then, of course, the alias. And that allows you to kind of differentiate, am I getting updates for wallet 1 or wallet 2 or wallet 3, in case you wanted to show multiple different wallets inside of the application. This live updates, but I'm fully scanned, and you can see that because the status now shows as synced. And what you'll see there typically would be downloading, scanning, synced. So your app can effectively wait for that synced operation before kind of going further. Right now, the ECC library has an annoying limitation that you don't really want to do anything as far as querying and definitely sending funds until you're synced. There's even some instability, at least in the version of the library that we are using here, or if you try to do some of those operations, you could actually crash. So wait for sync before querying things, which we'll do next in the next commit, which is getting a balance, getting transactions. All right, let's go back here. So next thing, get balance. This one's pretty straightforward. Once again, set some more component state variables that we can use for displaying the balance. And right on the synchronizer's asynchronous status updates, we wait for status to show us as synced. Once it's synced, we're going to call synchronizer.getShieldedBalance and then set that balance so that we can now see it. And we added another line to show the balance right after the address, right in the UI. Oops, let me go ahead and set that. Reset. Okay. So I may have to there's the address. The synchronizer needs to start. Here we are. And there's our balance that just showed up. Okay. And you get available Satoshis, and as many of you may know, Satoshi is kind of the Zcash equivalent of a Satoshi, and then total Satoshis. So available Satoshis are signifying the Satoshis that you can spend at that point in time, which could be different from how many you have in total, likely due to not having enough confirmations to spend. Paco can probably correct me if I'm wrong there. So those two numbers kind of are what are fed back by the SDK. All right, balance, fairly straightforward. Let's get the block height. That's also super straightforward. As you already saw, that was given in one of the updates. So block height. that comes out of the update, and we're just going to go ahead and set the block height so that we can display it. If your app wants to display block heights to the user, this is how you do it. Reset hard. And we're going to need the block height because that's what we're going to use to get transactions. So that's why we kind of go and query it and set that as state that's available through the rest of the component. And there's our block height. 217.6.118, which should match what we see right here. Cool. All right, now getting transactions. Now, I'm going to preface this with the ECC library is changing, and we're using some interfaces that are not going to be available going forward. So this will change in probably about a month. So pay attention or not as to what's available right now. We've made it fairly simple to get transactions. This is one of the harder things to do with the current ECC library. But looking at the process, we've simplified it. A few more imports. The birthday height is now part of the config here, where you get to specify, at what point do you want to start scanning for transactions. Let's see here. We set a transactions variable again so that we can display that. I'm going to remove the querying of the birthday height and instead going to use what's inside of the config file. You'll notice a lot of apps in Zcash, if you transition from one device to another, it'll ask you what's the birthday height, and you have to enter the birthday height that you hopefully remember from when you created the wallet. So this, in essence, is why we're putting it in a config file, and that you can specify that as part of the config. Local block height, here we go. This is the meat of what needs to be done here to get your transactions. So once we're synced, once again, you don't want to touch anything, getting balances and transactions until you're synced. So once you're synced, we are going to, see here, we're just logging the height. So we're querying the transactions between two heights, right? So the birthday height and then the local block height. Local block height is basically the current height as it is right now. So synchronizer, get transactions starting from birthday height and then ending in the local block height. And then we're going to set the transactions to then print them in here. Now this starts looking like more heavyweight React code. A flat list is simply a component that shows you a list of things. Right? There's the data, which is our list of transactions, and then a routine to render them. And in rendering them, we're just going to show the text of the date of the transaction, the TX ID, the value, and the address that it sent money to. Okay? And all of that shows up in the transactions array object that comes out of get transactions. That's this TX's object that we're setting. Okay. So we'll see everything we were printing out before, spend key, view key, address, update, and at the very bottom we should see a list of transactions. And I think this wallet, unless someone sweat my money, this wallet should have about 2 transactions in it once we set this commit. So let's set this commit here, reset hard. Okay, I might have to restart the app. And there we are, okay. Still 2 transactions, no one took my money. Okay, let's zoom in here. And so here, I'm just simply printing the transactions as they came in. There's the date in UTC time, there's your TX ID, and your Satoshis. As well, the second transaction, date that came in, and so this is Satoshis that I believe came in, and then date TX, oops, I think the app may have crashed here. Once again, unstable development environment. Let's go ahead and run that again. Oop, downloading, look, we're actually, oop, and synced, okay. So there's the 2 transactions. 3 million Satoshis came in, TX ID, and then 500,000 Satoshis went out to this specific address. And the existence of a to address is how you signify that it was actually an outgoing transaction. You know that it was sent out. Otherwise, the to address wouldn't be available in the transaction object that came in. And of course, you display that in some nice, pretty way inside of your app, however you choose to do so. All right. And then last, spending. Let's look at what it takes to spend money. A few more imports, but let's describe the actual code. We're going to set some variables that track the destination address, where the user wants to send money to, the amount they want to send money to, and of course you can send an encrypted memo and propose to someone, much like a few people have actually done on the Zcash blockchain. We're going to set a global component variable for the synchronizer, only because we need it outside of the scope that we were using it. Let's look at the meat of the code that's needed here. So the synchronizer, which we were using to get updates and whatnot, is inside of the scope of this use effect. We're going to need it outside of that scope. So we're just kind of setting it as a synchronizer2. Same variable, we're just calling it synchronizer2. All right, so in our UI, we're going to allow the user to have a little text input, how much to spend, allow the user to enter a destination amount, let the user enter a memo optionally, and then a button to send. And what's that button going to do on press? It's going to make sure all of these variables are not null, right? Otherwise you're going to return. And we just simply call a simple function send to address. Where are they going to send it to? They're going to send it to that address that they typed into the UI, the amount that they had typed in. There's the memo if it exists. If they didn't, we're going to send a blank string. From account index, accounts can have indices. Just know that if you're just using 0, if you're just using one wallet inside of the app, you set that to 0. And then you need to provide the spending key. That's the spending key you generated way back. That was like step 1 when we started the presentation. And then we're going to log the result, which will show the results of the actual spend. Okay, let's set that commit. Right, so you can see this UI at the top. That's the UI that we just built to be able to put in an actual address, put in an amount, and put in a memo. And so I have an address here. I'm just going to go and copy. Let's put that address. Comma paste. There, oh, there it was. Oh, I think the simulator died. Let's do that again. Okay. Address. There's the paste down there. Amount, let's send 500,001. Am I doing that right? 1, 2, 3, 4, 6. Memo. Hello world. And then simply hit send. Did I hit it? Go. I didn't provide a great UI to know that it was sent. Ooh, and there we go. I printed on the console the raw transaction, as you can see, gets spewed to the console. And there it is, so you know that it was actually sent. And the engine automatically queried the transaction. And you'll notice now that, oops, actually no, this one is still the old transaction. It won't see the, actually I take that back, it won't see the transaction until it does have a confirmation. So might take a few minutes, of which we'll probably be out of time here, but this should have been a successful transaction. This is the raw hex, and there's the TXID. Actually, I think we can look up this TXID possibly on a Zcash Block Explorer. Let's try to find one here. Blockchair has one. All right, let's put in this transaction, BDD9. Oops. I got lost in all my screens here. And that was transaction, you can see BDD9 that we just created. And let's see. Oh, couldn't find, so it's not quite seen by this Block Explorer yet. So it could still be processing. 1, 2, oops, I think there it is. August 1st, 9 a.m. And there's the third transaction. Here we go, right at the bottom. 500,001 Satoshis. And so it was seen by the synchronizer, queried, the app automatically found it, and updated the UI and showed it. So there you go. Thanks. And that is it. I think that's the last commit I put into the repo. So yeah, those are all open source. Feel free to give it a try, use it, build some apps. Let other people know to go build some apps, and let's keep pushing forward the Zcash ecosystem. So thanks, everybody. Okay.
Right. Okay, we have some questions coming in. I guess one question, and I have some questions as well. So, how the ECC libraries could be changed to make it easier to build wallets and other tools?
How could the libraries be changed? So one of the challenges of the library is that it's very tied to Android and iOS. So one of the pieces of feedback I've given folks is if they wanted to build something for the web, there's not really a good option there. And so building an equivalent library that uses, say, WebAssembly for a lot of the native Zcash Rust code, and wrapping that with a similar API would allow people to build desktop apps and web apps much more easily. So that's one of the nuggets. Others, I think, is less about easier to use for the developer, but more so kind of just a better experience to the end user. And I think this has already been talked about a lot, but faster synchronization. We know that that's coming.
Right.
Yeah.
Cool. And Edge is a multi-coin wallet. So what are the challenges of integrating Zcash into a wallet that already has a lot of other different coins?
Yeah, that is definitely a challenge. I think the biggest challenge is just resources. So obviously, every time you support a different blockchain, you need resources that can understand that blockchain, learn their SDKs, learn the APIs, and just the fact that so many blockchains change. Just like we're having to keep Zcash updated, we're having to keep, obviously Bitcoin updated, Ethereum and whatnot. That's easily the biggest challenge. Is you can't be completely heads down and looking at a single blockchain. You have to kind of keep your head up and go, okay, what's going on in this community? What's going on in this community? We do have a big focus on privacy, so we keep our head down and focused on a lot of the privacy-focused blockchains. That seems to be our niche within the multi-asset world. But for sure, definitely a big challenge to do multiple assets.
All right, so thank you, Paul, again. Great live demo. Everything went fine.
All right, thanks, everybody.